All right. Hello, everyone. I'm Dallas, and I'm a master's student in robotics at UCSD. For the second project in my motion planning class, we had the opportunity to explore some search algorithms and how they can be used in different environments to find a suitable path from a specified start to a specified goal. So, in order to tackle this situation, I built a Python visualizer application using the Python motion planning library, or the Pygame library. Sorry. I got to follow along with a tutorial from Tech with Tim and really learned a lot. So I highly recommend checking it out if you have the time and trying to implement it for yourself. So before we get into the design details, let me first demonstrate the application. So let's go ahead and take a look at the code. And I've already loaded the program in a Druid environment. So let's go ahead and run this and take a look at A star in action in a very complex environment like this with lots of tunnels and tight corners. But all I do is press spacebar and it deploys A star. So let's go ahead and take a look at it. All right, so now that we've seen the A star algorithm in action, let's go ahead and take a look at the code, talk about some of the design features we're seeing here. So I figured this would be a great and fun way to learn the algorithm as I've never implemented it before and wanted to be able to create something to put maybe on a resume or just a cool thing to share with people. So I made this Python visualizer with a tutorial from Tech with Tim, and we're using the Pygame library here to create a custom interactive grid environment where users can specify start and endpoints, draw obstacles, and visualize the A-star algorithm in action, finding the shortest path. So some of the key design features are, if we go down here, we can see that we can specify the rows, and this actually lets you specify the resolution of your environment, of your grid that you're placing on the environment. There's an interactive UI. Like I said, the user can click certain squares and then right click to erase them. And they can specify a start, a goal, and draw obstacles themselves. I'll do another demo so you guys can see that once I'm done talking about this. So in terms of the implementation, we're just seeing a program initialize a Pygame window. So we'll take a look at that right here. Or we're seeing the program initialize a Pygame window and it sets up various different colors for each of the nodes. So if we go ahead and take a look at RGB values we loaded in, we're using these to label different nodes. So for example, black is a barrier, orange is the start node, blue is the goal node, green is for the open list, red is for the close list, and so on and so forth. And then we retrace the path at the end in purple, and white nodes are unvisited nodes. So this node class that we implement, it encapsulates the properties and behaviors of a grid cell, including methods for setting its state and updating its neighbors based on the grid configuration. So you'll see methods right here that specify different operations. We have the update neighbors. We also have this heuristic function here. And the heuristic function calculates the Manhattan distance between 2 points, P1 and P2. So this metric is appropriate for grid-based planning environments as it only considers horizontal and vertical moves. And I'm a beginner to these algorithms, so I chose to fully implement the case of 2D. We also have grid creation here with the make grid function, and this creates a 2D list of node objects representing the grid. Each node's position and size are determined based on the grid resolution and window size. Our A-star algorithm is right here, we can see. And what this is doing here is it implements the A-star search using a priority queue to store nodes based on their F-scores. So we see the priority queue created here, and the F-score is being stored. The F-score is the sum of the G-score, which is the cost from the start node to the current node, and the heuristic score, which is the estimated cost from the current node to the goal node, the end. We also have a series of helper functions overlaid here, which are important for drawing the grid, handling user inputs, and updating the visual display. And then again, in the main function, this is where we initialize a grid, we handle the user interactions, we allow the users to specify the start and end points, we draw the obstacles, and then we can run the actual A-star algorithm. So overall, it's just a program that initializes a Pygame window and creates a grid of nodes. The user can specify start and end, draw the obstacles, and then deploy A-star with the press of a spacebar. And we're implementing A-star using priority queues and the Manhattan distance heuristic. And then the grid is continuously updated, so it has a refresh rate to show the progress of the algorithm and final path found. So with all those details being said, let me stop talking and show you some more cool examples. Peace.